Good morning. Welcome to Lesson 12, Volume of Pyramids. We're going to start with the key ideas on page 384. So if you look at this, we are looking at volume of pyramids, and so we're looking at the space that is within a pyramid. If we look at the algebra, the formula behind this, we have volume is equal to 1/3 times the area of the base. Just like in the last section, we're talking about the area of the base, not the length of the base, but the area of the base times the height of the actual pyramid. So if you look at the screen, you can see, again in pink is the area of the base, and then you're going to multiply it by the height. And it's the height of the pyramid, not the slant height, if you remember back to when we were doing surface area. So the actual height of the pyramid. Let's look at how this comes to play in example 1. With example 1, we start with the basic formula. Volume is equal to 1/3 times the base times the height. Again, that's the area of the base. And so if we look at this shape here, we are asked to find the volume of that pyramid. And so the area of the base is 48. And then you can see that it's like a right angle with the base and then the height of that triangle. And it shows that the height of the height of the pyramid is 9 millimeters. So we substitute in 1/3 times 48 times 9. When we simplify that, we get 144, and so the volume of this figure is 144 cubic millimeters. All right, continuing with example 2, we'll start with A. Find the volume of that pyramid. It's straightforward. But here you are going to have to find the area of the base. So if you look at the area of the base, it is a rectangle, and so it's a 3x4. And so if you look at that second line of the equation, that we have 1/3 times 4 times 3, and that's in red, right? And so that's showing you that that is the area of the base, and then times the height of that pyramid, which is 7. So when we simplify all of that, 1/3 times 4 times 3 times 7, we end up with 28. So the volume of that figure is 28 cubic feet. Now, looking next at this letter B, it's a little bit more tricky because it's a triangular base. And of course, with the pyramid, you also have triangles as your faces of the pyramid. And so if you look again at the area of the base, they do have the formula in red for the triangle, 1/2, and then the base of the triangle times the height of the triangle. And again, we are looking at the one that kind of looks like it's sitting on the ground per se. And so when they substitute this in, they end up with 1/3 times 1/2 times 17.5 times 6, and then times the height of the overall pyramid, which is 10. Simplifying all of that, you do get 175, so you end up with 175 cubic meters. When you're solving this, you are working with fractions. Remember that you do have to multiply the denominators and then multiply the numerators. And so just simplifying the fractions there, you would get 1/6. So then it would be 1/6 of all of that information. And remember, if you're taking 1/6 of something, it's really the same as dividing by 6. Okay? At this time, go ahead and try numbers 1 through 3, the on your own problems on page 385. Number 1, the answer is 42 feet cubed. Number 2, 186 2/3 inches cubed. And then number 3 is 231 centimeters cubed. All right, so looking at example 3, you can see that it is a real-life application problem, and we have 3 parts, or 2 parts to look at this one. The first problem, it says the volume of sunscreen in bottle B is about how many times the volume in bottle A. So we want a ratio from bottle B to bottle A. And so the first thing that we obviously have to do is find the volume of each of these bottles of sunscreen. So you can see the work that they did. And so with these problems, again, you are going to have to find the area of the base. The area of the base of these pyramids are rectangles. And so you end up with model A with an answer of 4 inches cubed. Model B is 6 inches cubed. So as I said, we want that ratio, again, back to that text in A, from model B to model A. So we take a fraction of 6 over 4. When we simplify that fraction of 6 over 4, we get 1.5 times, or 1.5 times. So bottle B is 1.5 times the volume of bottle A. All right? So then the next question is, which is a better buy, right? And so that's where we then have to take into account the cost. And so we can find the unit rate and find out how much that cost is when we divide it. So for bottle A, you can see they took the $9.96 divided by 4 because there were 4 inches cubed, and so we get $2.49 per 1 inch cubed. Bottle B, same sort of idea. You take $14.40 divided by 6, and you end up with $2.40 per 1 inch cubed. And so, of course, a better buy is the cheaper price, so bottle B here is the better price.